Hi, I'm Mike Regola. I'm a software developer at Chicago Bridge and Iron, or CBNI, and today I'm going to talk about the notebook interface package that we've developed to distribute programs to end users. Mike Regola from CB&I, and today I want to talk to you about how we use Mathematica at a large company and in industry, and in particular, a package we've developed called NotebookInterface that we use for building programs that we distribute to a large number of end users. So a little bit about us. CB&I is Chicago Bridge and Iron. We are a global engineering company, and we design and build storage tanks. We build everything from water towers to nuclear containment vessels, as well as cryogenic storage for liquefied natural gas and hydrogen, and more. So I've got some pictures here of our work. We design and build this stuff. And so we use Mathematica internally to design our tanks. We store inputs that define the tank, such as the loads, the materials, the geometry, and then we perform engineering calculations from those inputs to analyze the tank. So the way we operate is that my team focuses on developing Mathematica programs, so really notebooks where we've defined the inputs and the user interface, and then we distribute those to our engineers who actually run the programs and make the design decisions on the tanks. So our engineers are our end users, and we're sort of a software development group. So the Mathematica notebook is a nice tool for us for what we do, because it allows the engineers to add in their own supplemental calculations right inside the notebook alongside our content. And each construction project is a little bit unique, so people often have to add in extra code of their own alongside the approved program that we've built. So notebooks let you handle that, but we also need to be fairly strict in our program because we have to ensure we're following all the relevant building codes. So I'm going to tell you how we use this notebook interface package to manage those problems. A little bit about why we didn't use some of other options that are available. I've seen some really cool manipulate stuff before, but we have a whole lot of inputs for our programs, and you can't manage that with just one manipulate, one interface. In the past, we've done some placeholders, but this is like too open-ended for us. Allows users to make edits, and we can't provide feedback on what sort of stuff should be entered in force units and all that. So lately, I've also looked at these form functions built into Mathematica, and those are, I think, heading in the right direction. It's kind of what we want, but doesn't entirely behave like regular input. And I think you'll see what I mean as I show you some examples of how notebook interface operates. So let me show you what we do. So this cell here on the screen is an input cell generated using the notebook interface package. This is the result. So the way it works is that the developer writes some code. It looks a lot like how you would define a Mathematica form object. But that happens somewhere outside this notebook. And when that code is run, it generates a notebook with input cells that look like the cell on the screen. So you can see that this cell has some input fields and pop-up menus. It's kind of form-like, but it's actually just a regular input cell. If you evaluate it, it's going to, I think, work as expected. It sets the left-hand side to the current values on the right-hand side. And I think in a way that users can understand. So what that means is that our users can go ahead and add like comments or even their own code inside this same cell and then run it. and it's going to behave as expected. So the other feature you might see here is these red boxes around some of the inputs, and that's a validation function. So each input, you can add a validation function, again, like the built-in forms. And that function will run dynamically and update. So as the user enters in data into the forms, the red field will go away if their input is valid. So this is all what I call an input cell in the main notebook. So the interesting part of what Notebook Interface does is on this next slide, it's related to these input aid buttons on the right side of the screen. So if you click this input aid button, it opens up this extended window. It's actually an attached cell that sort of hovers over the notebook. And inside this attached cell, we have a sort of open-ended content where the user, the developer can add any sort of dynamics, manipulate graphics and stuff. Whereas in the main notebook is mostly just like a form. In the input aid, you can put any sort of graphical content that's going to help the user choose their inputs. So in this case, I'm picking out a plate material, the properties for a metal plate. And so I've sort of rebuilt what's in the notebook inside this input aid, but the key difference is that I have this drop-down menu at the top where you can pick a material by name. And we have a database of common building materials. So if you user selects one of the materials, it pulls in all the properties automatically for that material. And then also, like I said, you can do whatever is going to help the user pick their inputs here. We also calculate this allowable stress. So we're pulling that from the building code, the relevant building code. So we can provide this extra information for the user that you probably wouldn't want to put directly in the notebook, as it would clutter things up. But all this sort of stuff is going to help the user choose their inputs. So now the really exciting part is when I click Update Cell in this input aid, it pulls all the values back into the main notebook, and that's doing some pattern replacement magic on the box form of the cell object. But I think the user doesn't really need to worry about any of this stuff. This is all built into Notebook Interface. As far as the user is concerned, it just sort of works, and they don't have to worry about these details about dynamics and whatnot. I do want to mention that there's two routes to enter data into this cell. I could have entered it directly. I could enter these values directly into the notebook here, or I can use the input aid, and either way is fine. You get the same result. The cell will behave the same way, whether you use the input aid or directly enter data into the form. But there are some benefits to using the input aid that I'm going to talk about in the next couple slides. And we encourage our engineers to always use the input aid when they're entering data. Okay, so one benefit of using the input aid is tracking changes. So again, I got the same cell from the previous slides here with the plate material properties. And in this case, I've manually edited the cell a little bit. And this is very much a realistic scenario. The user's adding some comments. Maybe the materials change a little bit from our standard properties. So they've gone and made those changes. And the changes they made are highlighted in yellow. So let's see. Yeah, so the input aid still remembers the previous values that were entered into it. So when I open up the input aid, it still has the official values for this A36 steel. And if I click Update Cell here, it will put the old values back into the cell. So the input aid actually works based off of the cell's tagging rules. So that's how it remembers its state from run to run. And so between these two features, like, what it allows you to do is to sort of run a little experiment. You can try making a change and run through all the calculations later in the notebook. And then if you need to, you can revert it by opening up this input aid and replacing the old values. It's also nice for just sort of tracking changes. If you're sharing notebooks with people, you can see what's changed in the latest revision of the notebook if your colleague changes something. Okay, another feature these input aids provide is managing updates, or also sort of validating the structure of the cell. So I think I was saying earlier, we're worried about maintaining the structure of our notebooks. We don't want to be too open-ended. So this is how we enforce that the notebook doesn't change too much due to the user doing anything weird. So in this cell, again, I have the same cell from the previous slide. I've deleted some of the rows of inputs here. And that, that may happen because the user did something, or also because we've released a new version of our program where we've added additional inputs, and this is an old notebook. So in either of those cases, if you go ahead and open the input aid after making those changes, you get these warnings inside the input aid that tell you that it's missing some of the expected information. So if you now click replace cell in this input aid, the cell is going to be regenerated to the original structure. And if you remember, the developer wrote some code using NotebookInterface to generate this cell. So the cell knows what it's supposed to contain. And so we can simply regenerate the cell to fill out the missing inputs that were lost. And you can see we get back the original cell, and all the values have been put into it. So this sort of ensures that we have the program that we expect to have. We're running some calculations at the end, and as long as people are using the input aid, they should have all the information they need, all the inputs to run our analysis. So I've been showing a lot of simple left side equals right side form stuff, but I just wanted to mention that we can handle different sorts of structures inside this notebook interface. So in the last line of the cell, I just have a calculation or a function, like running a function. There's no input there, and that's also built into the structure of the cell when it was generated. So if the user deletes this line and opens the input aid, they can recover the expected line of code there. So I have another example here with a more complex input. This is really the whole point of Notebook Interface. I think my original example was just a basic idea of how it works. This is actually where it becomes very useful. So in this situation, we have like a matrix. It's just a modest matrix for us, maybe 10 by 10. We have much larger matrices, but it's not something you'd want to type in manually as a list of lists. So if you're interested, this thing is a load combination factors. It's a structural engineering thing. It's each row is representing a loading scenario on a tank, a combination of different forces exerted on the tank, such as wind and pressure and earthquakes. So this information comes from the building codes. So I've got a button here to load in the relevant building code, and some tools in here to modify the values in the matrix. And when you click update cell inside this input aid, it pulls the matrix back into the notebook. So not only is this nice and compact, but it's also stored securely in the notebook. So if I come back like a year later and run through this notebook, it will just, I can just set these load combinations to this matrix directly, and I don't have to go and click every input aid or open every manipulate to get my, my values back. Okay, I got one last little feature to show you here, and that's the instructions and help text. So there's this little I button at the bottom of the input aid cell. And if you click that, it expands this section at the bottom, and the developer can put any sort of information there they want. I usually add some instructions on how to use the input aid, or we do a lot of like technical documentation about how to design a tank. But that's nice for newer users to understand what's going on. It's another form of documentation. So we also use the built-in Wolfram documentation quite extensively. And this is just some additional documentation right at the point of use, I think is helpful. And by default, it's collapsed, so it's not bothering the more experienced users when they run through this. Okay, so now I've got the result of using, this is what we call a Mathematica program. It's the result built with NotebookInterface. And well, really, it's just the first chunk of a notebook, as these can be very long. You know, we have a lot of inputs. There may be dozens of these input cells with multiple inputs in each one. So this is what the user ends up seeing when they run our program. And I think it's relatively clean and clear what's happening. And one of the main benefits here is that the user can access any of the information built in the notebook. So I always use associations to store our data with the nice descriptive keys. And the user can see that where, you know, explicitly all these sets, which means that when they want to write their own content, they can use these inputs and they can understand where the data is going and make use of it themselves. So users typically work these notebooks top to bottom, and they'll add notes and calculations along the way. So, oh. All right, I do want to show a live demo. I've been showing a lot of screenshots. I've got a live demo here. And by the way, the code for this notebook interface package is on GitHub right now. I'm going to look at deploying it to the Packlet repository later today. But at the moment, you can use this resource function to download it straight from GitHub, which I'm going to try live. Oh, internet connections maybe a little bit slow, but it's going. Uh-oh. Well, slide. Well, in the meantime, let me tell you a little bit about how this works at a lower level, and you know what's going on behind the scenes. Of course, you can go look at our source code on GitHub, and all right, maybe it started. All right. Well, that's why I did all the screenshots earlier. I'm pretty sure if you use it yourself, it should work. It was definitely working yesterday. Oh. All right. So a little bit how this works lower level. The code that you're seeing on the screen, this is to generate the plate material cell I was showing in the first couple of slides. And this is sort of the code you would write as the developer to generate that cell. And you start with a what we call a cell template. That's going to generate the input cell and the structure of that cell. And cell template is a function. It has one parameter for each editable control in the cell. And then it works a lot like the way you define a form object, the built-in form objects, where you define type and field hints validation function. So it's a little bit, a little bit verbose, but a lot of it's very simple code. I always copy an existing function and modify it to do make new things. Then we also define the initial values for the input aid, and those are essentially tagging rules. And then the input aid itself is a function that you can do pretty much whatever with, any sort of dynamic content. And you can look at what we've got and sort of copy that if you're interested. And the final step is to actually write the cell into the notebook. And so you use this notebook interface function to generate the cell in the notebook. So all the user sees is the output and none of this code. Okay. All right, so I do have this little backup interactive thing here, which also does not work because it didn't load the package. All right, so I guess that's no good either. All right, here's the link for our GitHub repository, CB&I Storage Solutions Notebook Interface. You can check that out yourself. Make change or fork it, make some pull requests, whatever you want to do. And let's see. I did want to also touch on the how the input aid puts the data back into the notebook. So when you click update cell, we do some pattern matching this sort of pattern here, and plugs in the value in the input aid back into the notebook. So it makes this replacement, which is kind of cool. If you're interested in the box form kind of stuff, it's you can look at the source code and see what it's doing. It's pretty interesting. And as a final remark, I want to thank John Foltz and Lou DeAndrea because they wrote a lot of this stuff some years ago, and we've only built on it since then. All right, that's all I've got. If anybody's got any questions, happy to answer them now, or you can track me down later and ask me yourself.